Hello class, it's Mr. Gottlieb again, back with Unit 9, Day 5. I just noticed I mislabeled it on the worksheet, so this is actually Day 5, which you'll notice the assignment on Google Classroom, as well as Delta Math is labeled. I think the assignment on Google Classroom is labeled Day 5, but the assignment on Delta Math is labeled Day 2 because that assignment was given from a while ago, which is why it's Day 2. There are soon going to be Delta Maths daily, but they'll have less in them. So that they relate more to the specific topics that we're doing. It's just that the other assignment was already set up, so I'm not going to change it just because it's already there. So that one's going to be for the next like 3 days, and then all Delta Maths following that one should be one per day. Anyways, I had some requests from a couple of students in different classes, matter of fact, about other problems, as if they weren't covered in the video, but they kind of are, or they assume you at least remember something from the classes we did prior to when school got closed down for a while. So like number 4, we're going to be taking a look at numbers 4, 5, 6, 9, and 11. So I'm not going to do them all. I'm just going to kind of explain the things you might need to know if you're not sure what to do, and hopefully it'll be enough information. If not, message me again and we'll try again. All right, so problem 4 says, if placed in standard position, the angle of 11 pi over 6 has the same terminal side as an angle of which of these degrees? So let's take a look at what 11 pi over 6 is. Well, on the circle, if we know that half of a circle is pi, right? Oh, it's cut in sixths, so half a circle is pi, right? Radians. And it says 11/6 pi, so that means we're cutting the top half of the circle into sixths. So that's 1, 2, 3, 4, 5, 6. All right, so my circle's cut into sixths and I have 11 of these, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this seems to be 11/12 of the circle. So you could figure out what degree that is if you want. You can turn that into degrees by applying the same rules we were given before. So if you want to turn radians into degrees, you just put pi in the denominator to cancel out and multiply by 180. I'm not going to calculate the value for you. You should be able to do that yourself. So pretty much we're going to turn 11 pi over 6 radians into degrees. Next, the question says, what angle is coterminal to this angle? So this angle is here. So this is our angle. It seems to be something like 300 something degrees, or like negative 30 degrees if you're going the other way. So if we were to look at negative 150 as an angle, that would be going backwards over to here. So clearly, this angle is not coterminal to the other angle, right? So negative 150 is not coterminal to 11 pi over 6. Now 150 would be going the other way, so that would be here, which is clearly not coterminal to our 11 pi over 6 again, just referencing this angle over here if you're looking at it. Negative 30 seems to be pretty close. So negative 30 would be to go this way, 30 degrees. That seems like the same angle. And the last one was 240 degrees. So in standard position, 240 means 180 plus an additional 60, which is down here. So the angle in question is this angle. Does not appear to be the same. So it appears to be negative 30, but I will let you do the conversion yourself to find out for sure. All right, let's take a look at number 5 real quick. Number 5 says, in which diagram shows a angle rotation of 1 radian on the unit circle? Now, I don't know about you, but I know what the degrees are approximately for each of these. This is approximately 60 degrees. This is approximately 90 degrees. This is approximately 180 degrees, and this is approximately 360 degrees, assuming that these things are touching what they seem to be touching. So just convert 1 radian into degrees using the formula for converting radians to degrees. Now, it might seem weird because 1 radian does not include pi in it, but that doesn't mean you can't apply that. It just means that it's not a decimal value, like 2 pi radians, let me zoom in here, 2 pi radians just means 6.2 1.28 radians, because pi is equal to 3.14 approximately. So it just means that 1 radian was not a decimal value. It's actually a whole number of radians. So a student actually messaged me and said, so that means that it's the arc length that represents one radius distance. Yeah, so like if this is our radius, 1 radius around is about there or there or there. It's somewhere, but it would be 1 radius distance around the circle. So hopefully that's enough information to help you try problem 5. I had set up an idea to help you convert, like 90 degrees converted into radians would be multiplying by pi over 180 degrees, which is half of pi, but I could very easily have just write that as half of 3.14 radians and divide, so that would be 1.07, this is a 0.07, 1.5, 1.57 radians. So you don't need to write pi. I mean, usually you write pi because it means you're using an exact value instead of using like 3.14, which is an estimated value, but it's the same exact question. Convert and then look at the circle. All right, problem 6. This is very similar to what we were doing on Friday and on Thursday before we went away. That is breaking the circle down and seeing what each portion is worth. So if you look at this Ferris wheel, it's broken up into 1, 2, 3, 4, 5, 6, 7, 8 regions. So we should be able to figure out how much each of these is in degrees. Well, in degrees, 360 divided by 8 is 45. So each of these is 45 degrees. And we want to know how long it takes to get from up here to down here. Too far. From where we currently are to the bottom, so we can get off of the Ferris wheel. I think that's what the question says. Let's read it. Christine is riding in car 4 on the Ferris wheel, represented in the accompanying diagram. The Ferris wheel is rotating in the direction indicated by the arrows. The 8 cars are equally spaced around the circular wheel. Expressed in radians, so I mentioned it in degrees, but you can do the same problem in radians. The measure of the smallest angle through which she will travel to reach the bottom. So, I mean, this is 135 degrees. I can convert that to radians. Or I could have done this entire problem in radians, acknowledging that pi is 1/2 of a circle, and each of these is 1/4 of pi. And then you just have to count how many fourths of pi this is. All right, let's take a look at problem 9. You're always welcome to pause the video or go back or make a note of a question you want to ask me. Number 9 says, find a coterminal angle, the complement, and the supplement of 45 degrees. So 45 degrees on the circle is approximately here. Like this is 90, and that's 180. So a coterminal angle would be another angle that opens the same amount. So this is 45 degrees open, whereas a coterminal angle would go around the 45 plus another 360 to terminate in the same exact place. So a coterminal angle to this is just 45 plus 360. And you can add 360 again if you want. A supplement would just be to have this angle and try and make 90 degrees. So, a complement is to make 90 degrees. So if this is 45 degrees, what is the angle that you would add here to complete 90 degrees with 45? So 45 plus what equals 90? That's your complement. Similarly, supplements are angles that you would use to complete 180 degrees. So again, if this is 45 degrees, I want to get to 180. What is the missing value to complete that? So 45 plus something has to equal 180 degrees for the supplement. Okay, and once again, the coterminal, since I didn't write it down, coterminal is just rotating an additional full 360. So in this case, it'd just be 45 plus 360. And all of this can be done in radians. So problem 10, which is essentially the same question. Find the coterminal angle, the complement, and the supplement of 2 pi over 5. I apologize for the beep. I'm actually still at Madison, so whoops. But yeah, this problem can be done the same way. If you want, you can even convert this to degrees first, do everything we just did in degrees, and then convert all of those answers into radians. Or if you understand how the circle works, you shouldn't need to do that. So for instance, we're given 2 pi over 5. So that means the top half of the circle is split into fifths. So 1, 2, 3, 4. This is 5 sections. It's 2/5. So I'd want to find the angle that completes 90. I'd want to find the angle that completes 90 for the supplement. I'd want to find the angle, so that would be here. What is the measure of this angle? The angle that completes, the angle that would complete 180 degrees, that would be the supplement. And then I'd want to find an angle that is coterminal to this angle. So coterminal means it would go this amount and then around an entire additional 360. So we're going to do one more question, or at least look at one more question. I know I'm not answering the questions, but that's because these are problems you should be able to do, or you just needed a little refresher. So I'm not trying to give away all the answers. It defeats the purpose of doing the problems. In another day or two, if you guys are still having difficulty, I will gladly go over them a little more in depth. But there has to be a balance where you try the examples. So problem 11, the triangle actually wound up on the next page. So I'm not sure how that happened when I set this up. That's why I'm starting to put all the files as PDFs, so that shouldn't happen again. But either way, this is the triangle we're given. So we're asked to find theta. So we know this side is the opposite, and this side is the hypotenuse. So if you were to use a trig ratio to find that, it would be sine of 8 over, oh, not sine, excuse me, that's not the hypotenuse. I got a little distracted, I apologize. That's opposite and adjacent. So we would use SOHCAHTOA, and in this case we have the opposite and the adjacent, so that's tangent. So the tangent of theta is equal to 8 over 5. It should stand out to you if your hypotenuse is bigger than your opposite or adjacent. So that's kind of what I realized while it made me notice my error. Next, going to use my calculator to find the tan inverse of 8/5. So tan inverse of 8/5 is equal to, this is just with the calculator, whoops. Tan inverse of 8 divided by 5, as assuming my calculator's in degree mode, is 57.99 degrees, so approximately 58 degrees. I'll just call it 58 for the rest of this question. Does it specify what to round to? Nearest tenth, so nearest tenth would be 58 degrees because the 9 would round up, so say 58 degrees. Okay, next it says to find the measure of the third size using Pythagorean theorem in simplest radical form. So if you do a squared plus b squared, you'll find c squared. You can also find it using a trig ratio, so similar to what we were just doing. So I'll take this to the next slide. So now I know that this is 58 degrees. If I wanted to find this measurement, x, using a trig ratio, I would just say, I'll use this side and this side, because I only need 2 sides to go at my angle. So you need 2 sides and an angle. This is the adjacent. This is the hypotenuse. So in this case, I'll be using cosine, I believe. So SOHCAHTOA. So adjacent and hypotenuse is definitely cosine. So we'll write cosine of our angle, 58 degrees, is going to be equal to, I put that degree there, 5 over x. And we're just going to solve this equation. So I'll make it a proportion and cross multiply. X times 58 is x cosine 58. And 1 times 5 is 5. I want to get x by itself, so x is equal to 5 divided by cosine of 58. And then that'll just be given to me by my calculator. x equals, I'm just gonna use my calculator. 5 divided by cosine of 58, and I get x is equal to 9.4, I forget what the question asked me to round to, so I'll have to go check. It says round to the nearest tenth again, so rounding this to the nearest tenth, it's 9.43, so x equals 9.4. And the last thing I was asked to do in the last part of the question, again, pause if I'm moving too much, I apologize for movement. The last thing says to find the exact value of cosecant theta as a simplified fraction with no irrational denominator. Not sure we did this yet. Actually, that might be my fault if you couldn't do this one. Or could we? We can do this, yeah. Okay, so going back to the triangle. Going back, okay. So in order to do this with an exact value, I actually have to get x in simplest radical form, which means I would have had to find it using Pythagorean theorem. So let's just do that now. 5 squared plus 8 squared equals x squared. So we get 25 plus 64 equals x squared. Therefore, x squared equals 89, right? No. Yeah, 89. 2 plus 6 is 8, and 5 plus 4 is 9. So I want to know what x is, so I have to take the square root of both sides. Now, that means x is equal to the square root of 89. Now, I don't believe that has any perfect square factors, so this is the value of x. It should be approximately equal to 9.4 if we enter into a calculator. I'm sure they're very similar. Now, if we're asked for cosecant, now if we know our cosecant is the reciprocal of sine, so sine is opposite over hypotenuse. That means cosecant, which is the reciprocal, should be equal to hypotenuse over opposite. So it should be, so the cosecant of 58, did it say 58? Or theta? What is the cosecant of theta? So that's 58. So the cosecant of theta's exact value is equal to radical 89 over, what's the opposite? The opposite is 8. Okay, so I answered quite a bit of problem 11, and hopefully I've given you enough tips and hints to do the other problems on your own. If you have any more questions, make sure you ask them either on the Google Classroom, on PupilPath, or even through email, if that's the way you'd prefer to contact me. Again, this assignment isn't due until Tuesday morning, so if you have questions, keep asking. Again, I'm just putting things up early because I know you guys are a bit bored and you'd like to get some of your work out of the way. But I don't want to put up too much work early because I don't want it to overwhelm your classmates. So